Good morning, children. In the last class, we started with chapter 2, motion in one dimension. Okay. Now, before going into today's class, um, there are two important announcements. One is about the term examination. Okay. So, usually you have it in, you might have it anytime in August or September. We don't know the date exactly, but there will be an examination definitely. Okay. Now, this will be definitely different from the other ones in the sense internal marks will be more. Usually we give only for 20 marks for usually, but this time the internal marks will be either for 40 or 50. Okay, so this internal marks 40 or 50 will be based on Zoom class attendance. Maybe 10 mark for this, 10 mark for this, or 15 mark anything, 10 or 15, 10 or 15, and then 25 or 30 marks for this. Okay, so from now on, attending Zoom class is very, very important. Every class we take attendance, and if you miss, marks will be cut. Okay, then every day, whatever homework is given, you have to submit it through WhatsApp, my WhatsApp. Okay, I will send my personal number. No more to school WhatsApp. I will be giving my personal number tomorrow in your homework in MCB. I'll be putting my personal number and homework. Uh, if I the homework that was given for a particular day, before that day night you have to click a photograph and send it to my WhatsApp, and marks are going to be given for that also, and then your class tests. Okay, so maybe in these 1.5 2 months we might be having 3 or 4 tests. Those marks will be taken into account. Okay, so please pay attention. Not that 80 marks will be the external exam and one day before I'll study and get to it. No, every day your work is so important, so please pay attention. Okay, that's the first thing. Second one, your syllabus has been reduced. Okay, um, the board itself has reduced. They have not cut any chapter as such. All the chapters are there, but in every chapter some portion is cut. Okay, every chapter some portion is cut. Now unfortunately, in the portion that we have studied, in the chapter that we have studied, few portions are cut. Mainly, if you turn to page number 125 in chapter heat and energy. Okay, this third part, fourth part, and fifth part is cut, and fifth part we just have definitions. That means according to our chapter, according to our book, part B and C. Okay, part B and C not in syllabus. Okay, but we have done this already. See, there is a the sense greenhouse effect and global warming, only definitions are there. So I'll tell you exactly what to study. So, but we have already spent so much time in studying this. But anyway, we can't do anything. But for the exam, you're not going to study. You're going to only study a part and then little bit definitions from greenhouse effect and global warming. Okay. And another thing which will be really good news for you, that is in the chapter reflection of light, the numericals are cut. Okay, the numericals based on mirror formula, that is not there. Okay, so this is all cut. Okay, users are there, numericals are not there, and so all these you can just cut it off, and even this exercise is fully cut. I know we spent quite a lot of time in this also, but thankfully anyway, it is not there. Okay, so you don't have to worry about this. Like this, few portions have been cut from every chapter. Okay, so as we do every chapter, I will be telling you. Okay, most probably for this term you will be having 5 chapters. Okay, measurement and experimentation, lots of portion is cut in this also. I'll tell you later. Motion in the one dimension, many pages are cut in this also. Heat and energy, reflection of light, and propagation of sound waves. So these 5 chapters you might be having for the first term. Okay, so start studying, children. You're not having much time. In April and May we were thinking, okay, we'll go to school and study, but now we don't know how long this is going to go. You please take it seriously and start studying. Okay, otherwise it will become too hard. Okay, I hope you understood this. Okay, now let's go to the chapter. Turn to page 27. Page number 27. Okay, so this chapter actually has three parts: A, B, and C. B is fully cut. B part is fully cut. Okay, so again you'll be escaping lot of numericals in this. And C part also, these derivations are cut, but numericals are there. Okay, numericals are going to be there, but only the derivations are cut. Okay, so this also major portion has been cut. So anyway, A part everything is there, so we'll start from the A part. So the other day I explained few things, so we'll just quickly underline from the book. The first topic is scalar and vector quantity. As I told you the other day, scalar quantities are those quantities which are expressed or which have only their magnitude, okay, which have only a numerical value. They don't have a direction. Example: mass, length, time, distance, okay, like that. Vector quantities, these quantities have magnitude as well as direction to express them. Okay, they have magnitude as well as direction to express themselves. And examples: displacement, we discussed the other day, velocity and acceleration. Okay, so difference between scalar and vector quantities, it is asked as difference between many times. Okay, then come to the next page. Definition of rest and motion, not so important, just read through it. Okay, just read through it. A body is said to be at rest if it does not change its position with respect to its surroundings, while a body is said to be in motion if it changes its position with respect to its surroundings. Just read through it. Okay. Then you have another concept called, now this chapter says, this chapter title is Motion in One Dimension. Motion in one dimension. Now, what do you mean by that one dimension? Now, one dimensional motion means motion in a straight line path. For it means we are in this chapter we will be studying only about a body moving in a straight line path. This is one dimensional motion. What is two dimensional motion? Two dimensional means a body going like this. If it takes a turn and starts going in this direction, it was going in this direction, maybe x direction, now it starts going in minus y direction. In this there's only one direction, x-axis, it is just going in x-axis or in y-axis. But in this it was going in x, it then started going in y direction. So that is called two-dimensional motion. And then we have three-dimensional motion, that is possible only in space, where all three axes, x, y and z, all three axes changes can take place. Okay, so that's an idea about what it is, but mainly you should know one dimensional motion, because in this chapter we are going to study about one dimensional motion. When a body moves along a straight line path, its motion is said to be one dimensional motion. So that much is enough, the definition. Now come to distance and displacement. Distance definition: the total length of path through which a body moves is called distance traveled by it. Okay, then that's a definition. And then it's a scalar quantity. Its SI unit is meter, CGS unit is centimeter. Displacement: the shortest distance from the initial to the final position of the body is the magnitude of displacement, and its direction is from initial position to final position. So a body is going like this, eastward first and then northward. But when I say about displacement, I should join the starting point and ending point, and this will be the direction in which it is going. The person is going. In the sense, it should be a single direction. Here the direction was different here, and it is different. Okay, Okay, when we talk about distance, we are not worried about the direction, so we're not bothered. But when it is displacement, it should be in a single direction. So generally when we say, in this case, displacement 5 kilometer in northeast direction. Okay, this is northeast, so this is displacement is 5 kilometer in northeast direction. It's a vector quantity, SI unit meter, CGS unit centimeter. Usually vector quantities are represented like this. Okay, PQ, they put an arrow mark at the top. Okay, this is called vector. It means it has a particular direction. Okay, now distinction between distance and displacement. Magnitude of displacement is either equal to or less than the distance. Always displacement will, in this case if you see, distance is 7 kilometer, 3 4 plus 3, and displacement is root of 4 square plus 3 square, that is root 16 plus 9, that is root 25, that is 5 kilometer. So your displacement comes out to be 5 kilometers. So in this case, displacement is less than distance. Suppose in a case the body is moving from A to B. Okay, the distance between them is 5 kilometer. So what is the distance? Distance is also 5 kilometer. Displacement is also 5 kilometer. Why? It has moved only in a single direction. So either they can be equal or displacement will always be less than distance. But displacement can never be more than distance. Remember that. It will be either equal to or less than distance. It can never be more than distance. Okay. Then the second conclusion. Okay. The magnitude of displacement is represented by the length of the straight line between final and initial position. So you just have to join the initial and final position and find the length. That will be giving you the displacement. Okay. Then, okay, distance is always positive, but displacement can be positive or negative depending on the direction. Okay, this again is an important conclusion. Displacement can be 0 even if distance is not 0. This comes in the reasoning question sometimes. Displacement can be 0 but distance can never be 0. Now, what will be the example for this? Now, suppose a body is starting from A, it went to B. Okay, the distance between them is 5 meter. Okay, so the body moved from A to B and then returned back from B to A. Okay, went like this and then came back. So in this case, distance traveled will be 5 plus 5. Onward journey 5 meter, return journey 5 meter. So 5 plus 5, that is 10 meter. Whereas displacement will be, displacement, initial position is also this, final position is also this. So displacement will be 0. Displacement will be 0. So in this case, distance is not 0, but displacement is 0. Whenever a body starts at a point and comes back to the same point, displacement will be 0. Even if you take a circular path, if an object starts here, moves in a circular path and comes back to the same point, again, displacement is 0. Okay, so this is a circle of radius r. Okay, let's take this a circle of radius r. So what will be the distance for one full circle? One full circle. Distance traveled will be, okay, starting here, traveling till this. Distance will be circumference of circle, that is 2 pi r. Okay, so if you know the value of r, you can find it out. And displacement as usual will be 0 because it is coming back. Now, the homework that I gave you on the other day, body moving in circular path, but it is not finishing a circle, it is reaching a diametrically opposite point. It is reaching a diametrical opposite point. In the sense, half circle. It has covered only half circle, A to B, radius R. Now in this case, distance will be 2 pi r upon 2 because half the circle. So 2 and 2 will get cut, pi into r. So if you know the value of r, you can substitute it. And then displacement will be, here it will not be 0 because this is the starting point and this is the ending point. So what is the displacement? If I draw a line, straight line between starting and ending point, that gives me the displacement. And that is the diameter of the circle, r plus r, that will be 2r. So displacement will be 2r. Hope you understood it, children. Now one more example I'll do. Now suppose a body started at A. Okay. This is say 7 meter. A to B, 7 meter. At B, it returned and came to a point C, which is 4 meter. Okay. This total length is 7 meter. And this length is, so what will be the distance traveled? AB plus BC, that is 7 plus 4, that is 11 meter. Displacement will be, this is the starting point, this is the ending point. I just have to connect these two. So what will be the displacement? This length, that will be 7 minus 4, which is equal to 3 meter. 7 minus 4, 3 meter. Okay, so please note this 4 cases in your notebook. Okay, so this is say case 1, case 2, case 3 and case 4. Okay, case 1, body moving from A to B and B back to A. This one, A to B and B to C. The return journey is from B to C. This one full circle. The heading will be one full circle. This one, half circle. Okay, just travel only half circle or reached a diametrically opposite point. So what you do, okay, distance and displacement, put the heading case 1, case 2, case 3, case 4. Okay, so distance and displacement in every case you have to write it. Okay, hope you understood this. Okay, now difference between distance and displacement. It is the length of the path traversed by an object in a certain time. It is the shortest distance. You need not write this. You can write this as definition. Shortest distance between final and initial position. Second one, it is a scalar quantity. It is a vector quantity. Third one, it depends on the path followed by the object. It does not depend on the path followed by the object. Okay. Fourth and fifth, you can leave it. Come to the sixth point. It may not be 0 even if displacement is 0. Okay. So you leave this one. It's quite confusing. You just say this. It may not be 0 even if displacement is 0. It is 0 if distance is 0. It can be 0. No, leave this. It can be 0 even if distance is not 0. That is the sixth one. Sorry, fourth one. Okay, so you have only 1, 2, 3, 4 differences. That much is enough. Now these two can put a tick mark. It will be for reasoning question. Body is thrown vertical upwards from point A to this one. Okay, this is all we have discussed. Okay, then now come to the next topic, that is speed and velocity. Speed and velocity. Speed definition. Speed is defined as distance per unit time. Okay, so how much distance you traveled upon how much time you took to travel, that gives you the speed. Okay, so definition is only this much. Formula is this much. It is a scalar quantity, and then its unit is meter per second. SI unit meter per second, CGS unit centimeter per second. Okay, now there are four types: uniform speed, non-uniform or variable speed, instantaneous speed, and average speed. 1, 2, 3, and 4. So I can define four types of speed: uniform, non-uniform, instantaneous, and average. Uniform means whenever a body covers equal distance in equal intervals of time. That means when I'm traveling in a car, suppose first 1 kilometer I traveled in 1 minute. Next 1 kilometer, again in next 1 minute. Again 1 kilometer in 1 minute. This means I am covering equal distance in equal intervals of time. This is called uniform speed. This is called uniform speed. On the other hand, if suppose first 1 kilometer I finished in 1 minute. Okay. Now, practically this is not possible. If you go in a car, you know that you can't keep going in one particular speed. Okay, a speed breaker will come, then you have to father has to put a brake. So something else will come in between, they have to put a brake. Okay, so what happens usually, maybe first 1 kilometer you finished in 1 meter, but the next 1 kilometer you'd have taken 2 minutes because the traffic was so much and there were a lot of speed breakers, so it took 2 minutes for you. Okay, the third 1 kilometer, again you took 1.5 minutes. In this same distance, but you're covering in different time intervals. That is called non-uniform speed. Now, all practical speeds now is non-uniform. Okay, practically it's not possible to get a uniform speed. Non-uniform speed is what is happening generally when you go in a bus or a car. What is happening is non-uniform speed. Now, when you say non-uniform speed, that means speed keeps changing. You would have noticed that in your car there is something called speedometer. Car or bike or something, you have a speedometer which shows the speed. Okay, now that shows a speed which is called instantaneous speed. Instantaneous speed. Okay, instantaneous speed means speed at a particular instant. At that time, what is the speed? It will not tell you what was the speed before or after. Instant, at that instant, whatever is the speed, that is instantaneous speed, and it is given by speedometer. Then finally, you have average speed. Average speed, that will be total distance upon total time. Total distance upon time. The word total should come. Generally in speed, you will write only distance upon time. If it is average speed, total distance upon total time. Okay, so just the definitions are important. Uniform speed, if it covers equal distance in equal intervals of time, then it is uniform speed. Non-uniform speed, if it covers unequal distance, if it covers unequal distance in equal intervals of time. I've taken the other way. We have taken equal distance in unequal intervals of time. Both are correct. We have taken distance is equal, time is unequal. Okay, so both are right. And then third one, instantaneous speed. When the speed of a body keeps on changing, its speed at any instant. Any instant means that particular moment is called instantaneous speed. The speedometer of a vehicle gives the instantaneous speed. Then comes average speed. Average speed is total distance traveled upon total time taken. Okay, so then we have velocity. Velocity is the same as speed, but it is a vector quantity. Now, speed is distance upon time, but velocity is displacement upon time. Okay, the definition also is like this. It is the distance traveled per second by a body in a specific direction. Here, you don't write in a specific direction, but here in a specified direction. and the formula will be displacement upon time. It's a vector quantity because we're talking about direction. Now, same way you have uniform velocity, non-uniform velocity, then instantaneous velocity and average velocity. Now, the definitions are the same. In everything, you will only have in a specified direction or in a particular direction. Okay, same definition of what you had for speed. Only thing that is added is in a particular direction. Direction does not remain the same. Okay, and then instantaneous for a body moving, velocity at any particular instant. Okay, average means total displacement. You can just write total displacement upon total time taken. Okay, now in non-uniform or variable velocity, okay, this I'll do later, children. Now quickly see the homework for today. First is you will write all these 4 cases. Okay, write the heading as distance and displacement, case 1, case 2, case 3, case 4. Okay, you get questions in this based on this. That's why I'm making you write. Then you come to page 35, exercise 2A. You will be doing question 1, question 8. Okay, that will be your question 2. This we have not done. Okay, so you will be doing those 4 cases and then question 1 and question 2. Okay, and then you have to send it to me through WhatsApp by tomorrow evening. I'll be sending my WhatsApp number in along with tomorrow's homework. Thank you, children.